31 from where we left off yesterday. We were just started to get into compound interest, okay? We know that A at T is going to be the amount after a number, T is in years, so after a set number of years. R is the interest rate per year. N is the number of times the interest is compounded per year, and that's what we're going to kind of explore first thing. We talked about, like, if you only compound it once a year, then that means, you know, after that year, you invest a certain amount of money, and you earn interest. Like we talked about, you know, $1,000 at 10% interest, you get how much at the end of that year? $100. So total, how much is in your account? You had $1,000, now you earned $100, so you got $1,100. So then they refigure it again with the $1,100, right? And you take 10% of $1,100, which is $110. So that next year you earn $110. So then you have the original 1,000 plus the 100 you earned the first year plus 110 you earned the second year, right? And so the more amount of money, the more it's going to earn you, correct? That's if they only compound it one, you know, annually. What happens if, like, we do it biannually, meaning twice a year? So, like, every time they refigure it, it's based on a more amount of money, right? So it's going to be more amount of money. So we're going to kind of explore that to begin with, okay? So everybody got this formula down, because I will have to ask you to repeat it to me. Yes? Okay. All right, so let me just give you a second to write this down. A sum of $1,000 is invested at an interest rate of 12% per year. Find the amount in the account after 3 years if the interest is compounded annually, semi-annually, which would be biannually, twice a year. Quarterly, you told me, was every 4 months, right? And then monthly, and then daily. Okay? Any questions on that? So let me just give you a second to write this down before I begin. Here we go. A at T is equal to, say that, hold on, ground. P times the quantity of 1 plus R, all divided by N? R over N. Where? Oh, there's not a fraction in the middle? Okay, I don't know why I was thinking there is. Okay, I got you. That's a big set of parentheses, isn't it? Okay, so let's start plugging in things. Now, we're going to do several different problems with this particular example. The first one we're going to look at, what is it when it's compounded annually, meaning once a year, okay? So what's my principal? What's my P? 1,000, okay? So we're going to plug 1,000 here. 1 plus, what's the rate? What? Your 12%, that's your rate. Now, I'm not going to plug in 12, I'm going to plug in 0.12 divided by, what's N stand for? The number of times it is compounded per year, right? How many times are we compounding it per year? So in this case, I'm only compounding it once. Let me go backwards. So this is divided by 1, raised to the 1 times T is the amount of time. I want to know what's the money after how many years? 3 years, okay? And I'm only going to compound it once a year, okay? So I'm initially investing $1,000. So we're just going to plug this in. These should be fairly easy. These are all just plugging into formulas, okay? So if I were you, I would always work your exponent first. So this would be 1,000 times 1 plus, and you can do this part, just put it in parentheses, 0.12 divided by 1. What's 1 times 3? Raised to the third power. That's the only part. I think the rest of it can go straight into your calculator. But I would always do this first because sometimes that messes people up. Does that make sense? Especially when it's something other than 1 times 3. So I would always work the exponent first. So what's 1,000 parentheses 1 plus parentheses 0.2 divided by 1 close parentheses in the second parentheses raised to the third power? How much money? 1,404 and let's do cents. $404.93. Let's do dollars and cents today. Okay, everything rounded to the nearest hundred, so it's dollars and cents. So how much of that, let me ask you this. How much of that is my principal, like what I originally invested? 1,000. So after 3 years, how much interest did I actually make? $404.93. Okay, that's if I compound it yearly. Now let's go back and let's look at it, what it would be semi-annually. Now you told me that you feel like the more times you compound it, the more money it's gonna make. Let's see if that's true. Okay, so really it's going to be the same formula, except what am I changing now? I'm going to change the n. Okay, so now my n is going to, if I do it semi-annually, what will it be? How many times a year? Twice a year. Okay, and so this will be 2 times 3, which I'm going to go ahead and work this piece out and make 6. Okay, so tell me, if I do it twice a year, $1,000. Yeah. How do we know that can't be right? Because it should be higher. It should be more money. I was like 1418.52. So 1,418. So my question is, if we compound it twice a year, am I making more money? Yeah. And it's not that much money to begin with. But over time, it would be a lot more, right? We said, you know, like for example, that video that we watched yesterday. She started with 1,000. The first year she only made 100, right? Then they kept that in there. The second year she only made 110. But by the end of the 30th year, because it kept being more money and more money and more money, it grew exponentially. So it starts out slow and then it does. And she ended up making how much money after? It was like, I think it was $17,000 after 30 years. So like it is going to increase, but you know, to start with, we're only looking at after the 3rd year, so it's not going to be that much difference to begin with. All right, so now let's look at what it would be quarterly, meaning how many times a year? Is it so every 3 months? So 4 times a year, so this is going to become a 4. So I'm going to work that part out and make a 12. So how much money would it be if I compound it every 3 months, which would be 4 times a year? $1,025, 76, $76. So again, a little bit more money, okay, if I compound it every 4 times a year, every 3 months, okay. Let's look what it is monthly, meaning how many times a year am I going to compound it? It would be 12. So This would become a 12. So this would be 12, and this would be 36, right? 12 times 3. So if I plug that into my calculator, if I compound it every month, meaning, you earn so much per day. You earn so much per day. So at the end of the first month, I've earned a little bit of money. I'm going to invest that, compound it again, then at the end of the second month, same thing, invest what I've made it to there, compound it again. So how much money? $30.77. Anyway. All right, let's do one last one. What about daily? What if I would have compounded every single day? 300, so I'm going to compound it 365 times because there's 365 days in a year. You'll have to help me out on this one. What's 365 times 3? 1,095? 1,095. So how much total money if I compound it every single day for the whole year for 3? $33.24. 24 cents. Okay. So my question is our idea true? The more times you compound it, the more money it should make, right? So like if you go and you invest money, and they give you options and they say, do you want this compounded, yearly, semi-annually, quarterly, monthly, or daily? Like what would you choose? Daily, right? The more times you compound it, the more money you're going to make. So I don't know because I've never invested money. I should. Like it would be smart on my part to invest money as I'm planning for my retirement, but I haven't gotten that far yet. I haven't made it that far, but I should. There is a formula. We call this PERT. Why do we call this the PERT formula? That's what it says, P-E-R-T. Okay? So if it's compounded continuously, now, P stands for what? The principal. R stands for the rate. T stands for the time. What's the E? That's the 2.71828, I think. Number, yeah, that's the natural exponent E, and that you use because why would you be using E if I'm compounding it continuously? Huh? I would. So you would use this formula if you were continuously, like every second, all the time, compounding it. Okay? All right. So I think this is our last example. Any questions on this? I mean, really, it's just plugging into a formula and solving it. Okay? No, they don't. So I want you to find the amount if $1,000 is invested at an interest rate of 12% per year, but this time we are compounded continuously. What do you think should happen? More money or less money? More, because we're continuously compounding it. Okay? So the formula says this. A at T is equal to P times E raised to the RT. So our principal all right, what's our principal? 1,000 times E raised to the, what's our rate? 0.12 times 3, okay? And if I were you, my helpful hint to you to get this right is, because sometimes when people do e to the raise to the 0.12, the 3 doesn't like go with the exponent, just depending on how you type it in. Like if you're going to type it in, you better put parentheses around all of that. Does that make sense? But if I were you, if I could give you a helpful thought there, is I would go ahead and multiply 0.12 times 3. So I would make this 1,000 times e raised to the what? 0.36. And that's what I would do. So my question is, what's the amount if we compound it continuously? 1,433 and 33 cents. And that's pretty close to what it was daily. Does that make sense? Because daily is almost like it's doing it continuously, right? Every single day. Okay? But it will be slightly more because it's just a continuous compounding it over and over and over again. Eventually.